Now, these sum and difference formulas look a little wonky, but there's a couple things I want to point out to you. They're actually very easy to memorize, and it is something you're going to have to memorize. It is on the formula charts you filled out, so you can look them up, but it's just easier to know these things. When you look at the sum and difference of sines, meaning we're taking the sine of two different angles added or subtracted together, it has a whole formula. But what I need you to recognize here is that the top symbol goes with the top symbol. So when you are doing the sum of sines, the equation has a plus sign in it. And when you're doing the difference of sines, the equation has a minus sign in it. Do we see that? Okay. Now you might have thought this was just a weird typo and or might just like random choice to make this symbol. But what do you notice on the cosine of sum and differences? It feels upside down, but remember the top sign goes with the top sign. So if you're doing the sum of cosines, the formula has a minus sign in it. And if you're doing the difference of cosines, the formula is going to have a plus sign in it. That's on purpose. So that formula, that symbol is upside down on purpose. Just a couple things that will help us like see the difference in these formulas. Just looking at sine and cosine. What do you notice about the two formulas that's like the same and or different?
Sine has the plus on the top and cosine has the plus on the bottom.
Okay, good difference is that plus and minus are switched in the sines and the cosines. What else? We're comparing the sine to the cosine, and what do we notice about it?
Oh, those yeah, those match on each side and those don't match on each side.
So, being more specific with those.
So it's sine and cosine, and then cosine and sine, like it's opposite, and this one right next to each other.
Okay, do we see that? That's a huge way to remember which one you're using. In the sum of sines and the difference of sines, the sine and cosine are next to each other. Like they're not paired with the same thing. They're paired with each other. And in the cosine ones, first of all, it starts with cosine, and they're paired with each other. That's going to be huge for us to recognize the formula. Additionally, when we look down at tangent, we know that tangent is sine over cosine, which is where all of this comes from. This is just literally the sine equation over the cosine equation, but that's kind of gnarly to look at. So really what we use here is when you're doing the tangent of the sum of tangents, the formula will be tangent of alpha plus tangent of beta divided by 1 minus tangent alpha tangent beta. So we're going to kind of politely ignore that middle one because it has more going on. That's the formula we're going to be using. And if we're doing the difference of tangents, it's going to be tangent of alpha minus tangent of beta over 1 plus tangent alpha tangent beta. So they're kind of gnarly formulas. I get that. But their use is really nice. So we're thinking back to pre-calculator days when we had that beautiful table of values that you know all your trig functions for. You know your 30 degrees. You know your 45 degrees. You know your 60 degrees. You remember what I'm talking about? The table that I told you to memorize and never forget? We still need that. But here's a nice thing. If you have your formula chart, it's on your formula chart. It's on the front side of your formula chart. I would love for it to be in your brain, but I get it. We learn a lot at school. But you have quadrant 1 for all 3 of the angles. That's going to be very helpful today. Additionally, these formulas are going to be very helpful because they will allow us to do trig for values that are sums and differences of those cute numbers from 30 degrees, 60 degrees, and 90 degrees. I mean 45 degrees. So what I mean by that is, we're actually going to start with question number 2. I think it's simpler to start with this one. If we wanted to make the tangent of 15 degrees without using a calculator, I 1000% know you could get a calculator, you could type it in, but it's going to give you an ugly decimal. I don't want that. We want exact answers. So what we're going to have to do is get creative. What quadrant is 15 degrees in? Quadrant 1. Okay, so this is a non-tricky problem because it's in quadrant 1. That's why I wanted to start with this one. Is there a way we could combine 60, 45, or 30 to make the number 15? Meaning I want 2 angles, and I'm either going to add or subtract together to somehow get 15. 60 degrees minus 45 degrees. Isn't that 15 degrees?
Mr. Degree, man.
Great. So if I actually found the tangent of 60 minus 45, which I know values for tangent of 60, I know values for tangent of 45, then I can just use the formula on the top of this page without having to like use a calculator because we're in pre-calculator days. So the way that we would do this, 60 is alpha, 45 is beta. So the formula would be, here I'll pull this down so you can actually see it at the same time, tangent of alpha minus tangent of beta divided by 1 plus tangent of 60 degrees, that's alpha, tangent of 45 degrees. Now, whoa, where did everything come from? Great question. 60 is alpha, 45 is beta. So everywhere there was alpha, I put 60. Do we see that?
Wait, how do you know which one's alpha, which one's beta?
In the formula itself, alpha comes first. So alpha was the first angle you used, beta is the second angle you used.
Oh.
Specifically important for tangents and for anytime you're doing a difference that alpha and beta have to be in the right order. For addition can go in any order, so it doesn't really matter.
Oh, it doesn't matter when you use plus or minus, like which one?
In the formula itself, like this one.
Like can that one be like a plus and the other one be a negative?
So that's a really great question. I'm really glad you asked. In the tangent formula, we're doing a subtraction, which was the bottom symbol when we started. So I'm using all of the bottom symbols, meaning on the top there will be a minus and on the bottom there will be a plus. That has to happen for the formula. So again, in the tangent formula, we subtracted them to make 15, right?
Yeah.
So I want to use this subtraction, which means the subtraction is the second symbol.
Also.
So I use the second symbol for both of the signs. Oh, yes. Okay, we see? Yes?
Yeah.
Great. So here's the deal. Again, we're pretending like we don't have calculators, so we can't calculate 15 degrees, but we can do it like this. What is the tangent of 60 degrees? We should know this.
It's pi over 3.
But that's the radian version of 60 degrees. What is the tangent of pi over 3? So square root of 3. Okay, great. What is the tangent of 45? 1. What is the tangent of 60?
3.
And what is the tangent of 45? Oh my gosh, look at this. So if we just simply do that little multiplied step in the bottom, we would just have square root 3 minus 1 over 1 plus square root 3.
Do they cancel out?
Nope. That's the whole answer right there. They're exact answers because at this point, we don't have any way to make square root of 3 rational. There's a really gnarly way you can multiply by a conjugate, but I don't really care. This is what I'm wanting us to get to today.
It's gonna be on the test.
Okay? Now, FYI with this one, you don't have to write this down. You really could have also done this problem by doing tangent of 45 degrees minus 30 degrees, because isn't that still 15? But tangent of 30 degrees is square root 3 over 3, and I don't really want to put that number in a fraction, so I try to avoid using tangents of 30s at all possible. You can't avoid it every single time, but a lot of times you can avoid using the 30 degrees for tangent just because it's a not very good number, because it's square root 3 over 3. Yes? What's up?
Do we have to write down like all the steps in it?
What step were you wanting to skip? This one?
Oh, I was
Where you fill it in like this?
Yes, where it's pretty much.
So I thought like his hand like went all the way to the wing.
I would like for you to write it down while we're learning, because it'll help you recognize the formulas better. Okay, so we see how we kind of like use the formulas, figure out what combination of 30, 45, and 60 makes the number we want. Great. Let's go to number 1. Now I skipped this because this 165 degrees, what quadrant is that in?
2.
That's in quadrant 2. And in quadrant 2, we would have to use a reference angle to actually do this problem. So in quadrant 2, if this is 165 degrees, how much is left over right here? 15 degrees. So I'm actually doing the cosine of 15 degrees. Oop. But in that quadrant, is cosine positive or negative? So I'm doing the negative of cosine 15 degrees. So all that stuff comes back to haunt us. Why did we know that that quadrant would be negative? What's the acronym? That I use. No, that I use.
Oh, senior turtles never
I actually remember that one.
Never. Where did
All-Star Trig class, or whatever acronym you have to remember it. This is how we know that. In the second quadrant, the only thing that's positive is sine, and we're taking a cosine, so it has to be negative. Okay. For this problem, just to show you that it doesn't really matter how you make 15, we'll go ahead and do cosine of 45 degrees minus 30 degrees, because isn't 45 minus 30 15? Great. So now we look at the cosine equation. If we're doing the difference of cosines, the formula that I want to use is cosine of alpha times cosine of beta. Do I want minus or do I want plus?
You're gonna use minus.
Okay, so let's check. In the cosine, if we are subtracting them, what's the second symbol?
Oh.
Yeah, cosines are the opposite. So we're actually going to use plus. Okay, and then we have sine of 45 degrees times the sine of 30 degrees. So all I've done so far is fill in the formula with alphas and betas. You just have to choose the right formula. Then we refer back to things we already know. What is the cosine of 45 degrees?
Square root of 2 over 2.
Okay, what is the cosine of 30 degrees?
Square root of 3 over 2.
Okay, and then I'm going to add the sine of 45 degrees, which is
Square root of 2 over 2.
square root of 2 over 2 times the sine of 30 degrees, which is?
Square root of 3 over 2. Square root of 1.
Which is just 1. But yeah, 1 over 2. Okay, oof. That's all from the chart. Hopefully that's in your brain. If not, please have your formula chart out. Because at this point we're past that. Okay, and then we're just going to do this multiplication. Now we don't turn to a calculator because it would give us decimals. We don't want decimals. You think back to Algebra 2 when you learned about radicals. There's a property of radicals that says if the index matches, you can just multiply the numbers underneath the same radical, which means all we're going to be doing is square root of 2 times 3, which is 6. And then fraction rules are top times top, bottom times bottom, so this is 4, plus square root of 2 times 1, which is square root 2, over 4. Now just to clean this problem up, I like to write my answers as one fraction. Since they have a common denominator, I feel like that's simpler. So with this common denominator of 4, this would be negative square root 6 minus square root 2. I distributed the negative 1 at the same time. Okay, well, let's back up and make sure we understand that question. If there are no more questions, we're going to go to number 3.
I'm not okay.
What quadrant is the angle in number 3 in?
2.
2, which means we're going to have to do something to figure out the reference angle. So if this is 105 degrees, what's the reference angle?
175.
Wait, why
No,
do we
75.
Say again?
why do we have to find the reference angle for that one?
It's outside of quadrant 1.
I said
Also,
I thought that's better 1.
Because we can't combine, another reason is we can't combine 30, 45, or 60 in any way to make 105. Well, I guess we technically could, but we're going to stick with this way. Because there will be times you want an angle you can't add up using those angle measurements that we know without having to use a calculator. So we look at the smaller angle created in that quadrant, which is the reference angle. Now in this quadrant, will I have to put the minus sign in front of this? No. Why not? Sine is positive in quadrant 2. So this really, all we're going to be finding is the sine of 75 degrees. Is there a way we can combine the numbers 30, 45, or 60 and make 75? 45 and 30, right? So for addition, it doesn't matter what order you do it in. And honestly, I don't do it in a particular order every time. You could go smallest to largest every time. I just kind of go however I feel. Be honest with you. Okay, let's practice right now making sure we can fill in the formulas. So using the formulas on the top or on the front page of these notes, can you fill in the sum of sines formula with 45 degrees and 30? I'll give you a second. We should have used the sine version, which is the one that has sines and cosines not matching, but like all together. And it's the one where plus means plus. Because in the formula, the plus is on top and the plus is on top. But at this point, we know all of these individual values. The sine of 45 degrees is square root of 2 over 2. The cosine of 30 degrees is square root 3 over 2. The cosine of 45 degrees is square root 2 over 2, and the sine of 30 is 1/2. So when we multiply these, again, the rules that we learned in Algebra 2 that you might have forgotten means that if the index matches, which it does since they're both square roots, we can multiply those together. That's square root of 6 over 4 plus square root 2 over 4. And then we can just combine that and simplify it into square root of 6 plus square root 2 over 4.
Question.
Yeah.
So on the number one question,
Mhm.
it was the same one.
Same one meaning
Like the second and last step, it was like the same one as this one right here.
they're going to be very familiar values because we're only using sine of 45, 30, and 60 or cosines of those things over and over again.
I answered my own question. I was going to ask why is it negative, but then I realized you brought the negative all the way down.
Correct. The negative came from the fact that cosine is negative in quadrant 2.
And that's what my brain does.
Okay. Can I make it just, it's not different, but it's going to feel harder. Because look at number 4. What kind of angle measurement are we using in number 4? Radians.
Oh no.
Oh dear.
It's lunch.
It's not quite. So we will have to do this in radians, and we're going to keep it in radians. So don't switch it to degrees. I want us to try in radians. So here's something that might be helpful. Guys, a lot of times when you're dealing with radians, the denominator is going to be 12. That's not something listed on your charts. So we need to figure out what all of our values are with a denominator of 12. The radian values we're used to are pi over 6, pi over 4, and pi over 3. If I give pi over 6 a denominator of 12, what should be in the numerator? 2 pi. If I give pi over 4 a denominator of 12, what should be in the numerator? 3 pi. And then for pi over 3, what should it be? 4 pi. Okay. Since those are the numbers with a denominator of 12, which is pretty common in the kind of questions I'll ask you, otherwise you just do this step for yourself, is there some way to make 7 pi's over 12? What? No, sorry, we're adding these numbers. Is there some way we can make 7 pi?
Yes, 3 pi over 12.
Which means that sine of 7 pi over 12. Oh, I totally forgot to do something. What quadrant is this in? Oof.
Probably
Quadrant 4.
3.
Oh dear. Okay, so 90 degrees is pi over 2, right? If I make that with a 12, what is pi over 2?
6 pi.
So that's 90 degrees right there. Is this bigger?
Yes.
Yeah, so that means this is in quadrant 2.
See, I told you to half my answer.
Which means, oop, so sorry, that this is the angle 7 pi over 12. What's the reference angle in radians? If that's 7 pi over 12, and we know this is 12 pi over 12, what's the reference? 5 pi over 12. Because 7 plus 5 is 12. In that quadrant, is sine negative? No, so we're good just making it 5 pi over 12. Now I know fully that for this example, and this is why I messed up, you totally could make 7 when you add 3 and 4. But really, and because a lot of times that won't work, you will have to find that reference angle first. Is there a way we can combine those purple numbers to make 5 pi's?
Yes.
2 pi over 12 and 3 pi over 12, which really means we're going to do pi over 6 plus pi over 4. Right? Because those were the two values right there. 2 pi over 12 is pi over 6. 3 pi over 12 is pi over 4. And the reason I want to put it back into those nice cute angles is because I know those off of the chart. When we use the sine formula here, which would be sine of pi over 6 times the cosine of pi over 4 plus the cosine of pi over 6 times the sine of pi over 4. I know those values off of my chart. Maybe not as thoroughly as I know the degree versions of it, but we need to get there because this will be very helpful in the next few days. What is the sine of pi over 6? Which is like the sine of 30.
Oh,
Oof, we were so good at this. Dust off those cobwebs. Let's get it back. What is the cosine of pi over 4?
2 pi over 2. Square root of 2.
Square root of 2 over 2. How about the cosine of pi over 6?
Square root of 1.
Square root of 3 over 2.
Oh yeah, it's 3 over 2.
And then sine of pi over 4?
Square root of 2 over
2 over 2.
And so, again, yes, you kind of noticed this earlier. A lot of the answers are very similar, but it's because we're relying on the same 3 angles the whole time.
We can't do that forever.
Yeah. I'm trying to rack my brain if it won't ever, so I don't want to say yeah and then be wrong. But I did all of the homework problems for the next couple of days, and I don't think I did anything other than use those angles or have some. Okay, let's go on to question number 5. Now, question number 5 is the same sort of question where we're going to find the exact value, but it is still in radians. So just to help us out, and because it's on the other side of the page, I'll go ahead and rewrite all of our values that we know with a denominator of 12 instead of the normal denominators. Okay, now is there a way, wow, I almost forgot the question again. What quadrant is pi over 12 in? Quadrant 1, so do we have to do anything weird? No, we just need to find a way that we can combine the values we do know to make 1. Any of them will work. Which one do y'all want to do?
2 and 3.
2 and 3. So we would do what with 2 and 3? 3 minus 2. So we were going to do pi over 4 minus pi over 6. Yes? So now this is cosine. So yeah, we're on the back, so you'll have to flip a little bit. But remember, cosines are the ones where the values are together. So the cosines go together on this one. So this formula is going to be cosine of pi over 4 times cosine of pi over 6. Do I put a minus or a plus?
Plus. No. Minus.
Ooh, you were right the first time. Cosines are the opposites. So this is plus. Then we're going to have sine of pi over 4 times the sine of pi over 6. Which all of those values we should know. They're on our table. They're in our head. Cosine of pi over 4 is square root 2 over 2. Cosine of pi over 6 is square root 3 over 2. Sine of pi over 4 is square root 2 over 2. And sine of pi over 6 is 1/2.
That's good.
Mm-hmm.
Do we need to memorize the formula? Like the cosine alphabet?
At this point, you will be able to use your formula chart on pretty much everything in class.
Even unit tests?
Yes.
No way.
So I can make notes on there.
No, it needs to be just the formula chart, please.
Are you gonna fact check the papers?
And now that you give me that idea, I probably will. Thanks for giving me that idea.
Invisible.
Oh, I didn't do anything. Use grab an expo marker.
Imagine you just grab like invisible ink.
And so voila, there we have it.
So are all these just the same answers?
They're variations of the same answer because, again, we're only using 30, 45, and 60, so there's a finite number of combinations of those things.
I bet you the next answer to the question is negative square root of 6 plus square root of 2.
It will not be because the question changes in number 6. In number 6, it still wants the exact value. Ooh. Sorry, I don't know what happened to my voice just then. But we have it already in the formula. What formula is this? Is this for sines or for cosines? Sine. And is it the sum of sines or the difference of sines? sum. So really, this is like 25 degrees plus 35 degrees, right? And what is 25 plus 35?
60.
And what is sine of 60? That's something we know.
Yeah, I knew.
Oh, that's it?
That's it.
Really?
Yep.
Wait.
So what I'm asking for you to do is recognize which formula it is, and all of these should become one of the trig values you should have memorized. So I recognize that this is the sine formula because sine and cosine are together, not cosines and cosines. Additionally, I know it's addition because in the signs are the same. Cosines, the signs are opposites.
So what happened to the other 2 degrees? Like you use 25 and 35, but you don't use the 1.
That's a great question. This is alpha. Oops. This is alpha and beta, alpha and beta. So then I just used it in the formula as alpha and beta.
Oh, okay.
Does that make sense, how I did that? And then they should combine in some way that give you a value you should know off the top of your head. So if we look at number 7, is this a sines or a cosines? How do we know it's cosine again? Yeah, cosine and cosine go together, plus it starts with cosine. Which means this is actually the cosine of what 2 angles? 20 and 10. Now, am I adding or am I subtracting them? I'm adding them for 2 reasons. 1, I told you you should know all the values, so you don't need to be 30. And 2, because cosines are the opposites. So the sines in the cosine formula should not match. Does that make sense? Which really, this is the cosine of 30 degrees. And what is the cosine of 30 degrees? Square root 3 over 2. That's the exact value. Ooh, and then we got a tangent. Tangent we haven't used in a minute. But remember, it's very obvious this one's tangent because it says tangent. So this is the tangent of 10 and 20. Am I adding or am I subtracting 10 and 20? I'm adding because tangent follows the sine of the top, since the top is sine, not cosine. So this is going to be whatever sine is in your sum or difference formula. That means this is actually the tangent of 30 degrees. And what is the tangent of 30 degrees? That's it. Square root 3 over 3. But then, of course, there's radians. And oddly enough, these radians do not have the same denominator. So we'll have to do something about that. Now, first things first, is this going to be sine or cosine?
Sine.
Sine. And am I adding or am I subtracting these? Subtracting, because for sine, it's the same sign. Okay, but I can't add or subtract those fractions until they have a common denominator. So I'm going to go ahead and make them have a common denominator. This is 3 pi over 12 minus 11 pi over 12. Which is what?
8 pi over 12.
Ooh,
Oh,
negative 8. But yeah, okay. So here's where something that we haven't quite used yet comes in. And this is only like sort of something we need to know. Everybody look at the very front of this packet for what's called the even and odd identities. In the even odd identities, when sine has a negative theta, the very front of your packet, what does it say that is equal to? Negative sine of theta. So really, I could rewrite this as the negative sine of just the positive version of this. I'm allowed to do that. That's the even or odd identity. For sine,
No, we gotta be doing this now. Oh,
no, it's fine. It's still not that bad. Cool. Well, 8 pi over 12, I don't really know any of my trig values for that, so I'm just going to keep simplifying this down, and maybe it's something that I recognize. Can you simplify 8 pi over 12?
yes. Yeah.
To what?
4 pi over 2. No, 2 pi over 3.
2 pi over 3. Now, that's not exactly one I know, but I do know a bunch of other values when it comes to pi over 3. So if I think about where 2 pi over 3 is, it's here. Oops, why did I write a 12? Why did I write a 12 again? Oh my goodness. So what is this angle right here? Pi over 3. So do I know what the sine of pi over 3 is?
Yeah.
What's the sine of pi over 3?
No, square root of 3 over 2.
Wait.
Square root of 3 over 2.
Hey, let's
And
go
it's
there.
just negative because of the even or odd identities.
Really?
Mm-hmm.
That's good. Oh man, I forgot. Never mind.
So if you're getting a negative angle, that's when you need to turn to those even or odd identities. It has to do with whether the function is truly even or odd, like fold on the y-axis or twist around the origin. That's why these things happen. But basically, sine and tangent are the same. Cosine will never be negative. Okay. Last one like this.
Could there ever be decimals in this stuff?
No, because I'm asking for exact answers. I mean, maybe 0.5. That would be the only decimal. Is this one going to be sine or cosine?
Cosine.
Cosine. So it's cosine of what and what?
Square root of.
Wait.
Square root of.
Cosine of pi over 12 something
Oh.
Minus.
plus. Remember, cosines are the opposites.
Oh yeah.
So if I add those two angles together, that's just 2 pi's over 12. It's nice. They had the same denominator. Didn't have to do anything for it. But I don't know anything with denominators of 12s. Oh, but we see, yep, it's what? Pi over 6. And what is the cosine of pi over 6? Oh, you're right there.
Oh, pi over. That's gonna be square root of 1. 1 over 2. There we go.
So there's the time it would be 0.5. That would be the only time you'd be able to answer with a
Square root of
decimal.
1 over 2 is the same thing.
It is the same thing technically.
Yeah.
So the reason that this topic is tucked into the identities packet, because it doesn't feel like we've been using identities, even though we are, because identities are like formulas. One of the reasons that it's here is because of this problem right here. It says establish the identity that sine of alpha plus beta plus sine of alpha minus beta is 2 alpha sine alpha cosine beta. Okay, and by establish, we really mean prove. Because we can use the identities from the sum and difference formulas, these formulas, to continue to do proofs. So my question for you is, what is this formula when there's a plus sign for sine?
Negative.
No. So there's a plus, right? So it's sine of alpha cosine of beta
Oh, so it's not-
plus cosine of alpha sine of beta. Okay, cool. All I've done so far is used, and we're going to do this piece by piece because, again, it's a proof. All I've done so far is use the sum and difference identities.
We have to write alpha like that.
That is the correct way to write alpha, yes.
It's like a D.
No,
It's a fish.
but it's not an A. It is an alpha.
It's very close.
Okay, now we have another formula for sine of alpha minus beta. What is that formula? I'm just rewriting this part right here. What is the formula for sine of alpha minus beta?
Cosine beta.
Uh-huh. Minus.
Cosine alpha sine beta.
Great. And again, because this is a proof, we explain what we did. That time we did the sum and difference identities again. It is a lot of words, but does anyone notice what's going to happen here?
Cancel out
What cancels?
everything.
Nope.
No.
Not everything.
Just the
It's gonna be the
cosine.
right parts.
Yeah.
These two, right? So then I'm left with sine of alpha cosine of beta plus sine of alpha cosine of beta. And all I did was cancel.
So I'm trying to do it in this class.
Now look at our goal. Our goal was to get it to look like this.
Do we have to write on the steps?
The next step? Well, we got to finish it.
Do we have to write out the steps?
Yes, it's a proof. But what's nice, aren't those the same thing? So we can just double them. It's the sine, 2 sine of alpha cosine of beta And voila. Once we combine our like terms, we have our proof. So we can now add these formulas into other identities we've been working with. So it can be part of larger proofs. Most of the questions you'll see are going to be like the other practice problems on this set of notes, but it's definitely an option. Hey, can I grab your attention for a second? I made a mistake. Cosine of pi over 6 is not 1/2.
Oh, it's
Square root of 3 over 2. My bad. Y'all should tell me when I do something silly, guys. Come on. Sorry. Cosine of pi over 6 is square root of 3 over 2. My human was showing. So sorry.